This is a talk in honor of Professor Rajiv Sangal. And the title is Alice in Wonderland, Navigating the Landscape of Multilinguality for NLP. So the main message of the talk is to say that multilinguality has become inevitable, not only because of the presence of many languages in the world, but also because of the need for solving the data scarcity problem. Now, as Professor Srinivas Bangalore had begun, I'll also begin with this picture and the very well-known shloka, Guru Brahma, Guru Vishnu, Guru Deva Maheshwara, Guru Sakshat Parabrahma, Tasmai Sri Gurave Namo. So this slide shows pictures of my two gurus, Professor Vinit Chaitanya, with whom I did my master's project, and Professor Rajiv Sangal, who was my teacher and also was in my thesis committee. And with both of them, I have had continuous interaction, many debates, many discussions. And this talk is a homage to them. Now, maybe since the talk is on multilinguality, let me pay my homage in two languages. Okay. Yeah, so this was just launched yesterday as part of the Bhattacharya project. And I have not tried this sentence, so let me hope it works. I pay homage to my teacher, Professor Rajiv Sangal, who has taught me natural language processing.
मला नैसर्गिक भाषा प्रक्रिया शिकविणारे माझे शिक्षक प्राध्यापक राजीव संगल यांना मी श्रद्धांजली वाहतो.
So this is okay, sir. This is English to Marathi and the pipeline ASR, MT, and then TTL. Okay. Okay.
तर हे ठीक आहे. इंग्रजी ते मराठी आणि पाईपलाईन रिक्त आहे आणि नंतर TTL.
Sorry.
आल.
I hope it will be okay now.
Close the tab. Close the tab.
Close the tab.
मला आशा आहे की मी तोडले.
No, it's gone. Okay. Okay, so to begin the talk proper, now we all remember this very beloved character, Alice in Lewis Carroll, and she enters a strange world where there are grinning cats without a body, a very busy rabbit, red queen, white queen, and so on. So for many of us NLP researchers, we navigate in a multilingual world, a very strange world. For example, machine translation between Konkani and Marathi, question answering in Tamil, information extraction, information retrieval in Bengali, Turkish, sentiment and emotion analysis in French, and so on. So ours is a very varied and complex world. Now, I just composed these poems to emphasize this point that both intuition and implementation are important. So these are the lines I wrote. Scientists ask why, engineers ask why not. Scientists wonder at what is, engineers wonder what could be. World couldn't do without either. Scientists study, engineers make, and ever the twain shall meet. So we need both intuition and implementation, especially in this world of deep learning, machine learning, and so on. I believe it was Diptiji who emphasized that after the talk that Professor Rajesh Bhatt gave, that the EA construction, the equivalent construction in Bengali is A. এই যে তোমরা এসছো কি বলছো? So this A, what is the role of A? And it becomes important when we annotate the data. So two places where linguistics and task understanding play a paramount role are data annotation and error analysis after we have obtained the output from the machine learning model. So we need both science and engineering for constructing successful systems. Now, when we look at the world of multilinguality, if we look at Wikipedia, for example, English leads the pack with the amount of corpus, resource, tools that it has. So, for example, in Wiki, English has about 6.4 million articles. German, French, and Spanish are in the 2.52 million club. Japanese, Chinese are in 1.3, 1.1 million club articles. And when we come to Indian languages, Urdu, Hindi, Tamil are about 150,000 articles. Marathi, Malayalam, Telugu are about 70 to 80,000. And Nepali, Gujarati, Kannada, about 30,000, Oriya, 50,000. So these are the numbers to emphasize the distribution of languages in terms of their corpora. And it is very clear that these languages content are increasing, and their demand for a space in the NLP world, where NLP is now synonymous with impact on society, usefulness, and so on, cannot be ignored anymore. So there is this also very important point about language typology, where language properties and features have to be taken into account when we build computational systems. Coming to the Indian language families, we have Indo-Aryan, Dravidian, Austroasiatic, and Tibeto-Burman families. And in Indo-Aryan, we again have Shauraseni, Maharashtri, and Magadhi families. Punjabi, Gujarati, Western Hindi belong to the Shauraseni family. And Marathi, Konkani, and Maharashtri, Eastern India, Assamese, and Bengali are in Magadhi family. So understanding these families and their commonalities and distinctions are very important, mainly from the point of view of transfer learning, as I'll show during the course of the talk. Now, we have had a long journey in natural language processing, especially with focus on Indian languages and multilinguality for about last 25 plus years. We started our work in IIT Bombay with interlingua-based machine translation called the UNL project. Then we built the Indian language wordnets. We wanted to see the use of Indian language wordnets in many NLP problems. Multilingual word sense disambiguation was always an important concern when all the wordnets got built. Then when statistical machine translation came, we worked on many Indian language machine translation systems, and so on. And then when neural machine translation came, we are thinking of how to harness again multilinguality for creating machine translation systems. So this journey has been long, and we have looked at languages and their properties very closely to build computational systems. And many of these works are with many generations of students, colleagues from IIT Bombay, IIT Patna, and so on. Now, the main challenge of natural language processing is ambiguity. And since in India we use code mixing very freely, the ambiguity gets amplified, I would say. I would like to give you a very interesting example of an actual conversation between two ladies. This is an actual WhatsApp conversation, and ambiguity arose, communication broke down because of code mixing. So lady A wrote on WhatsApp, yesterday you told me about a shop that sells artificial jewelry. Ki naam jano? Bengali. What did you say the name was? Both the ladies are English educated, and they use code mixing quite freely. So lady B wrote NYKAA. Lady A gets very offended and says, what do you mean, madam? Is this the way to talk? Lady B says, Kano ki holo? Why, what happened? So you see, both the ladies are English educated, they are using code mixing, and communication breaks down. What is the reason? NYKAA, Naika, happens to be the name of a fashion shop, very successful fashion industry. And this coincidentally is homophonous with a Bengali derogatory word, Naka. okay, which means a pretentious person who feigns ignorance. So the communication broke down because Lady A thought Lady B was using a derogatory word for her. Okay, this is a pure concatenation of circumstances. Both the ladies are English educated. They use code mixing. Both happen to be Bengali, and a Bengali derogatory adjective is homophonous with a named entity, which is Naika. Okay, so because of this, the communication broke down, and it happened because of ambiguity. This is an actual example. Now, coming to multilinguality, we created these 18 languages WordNet, all linked to Hindi. And here is a very quick demonstration of the system. So if I take the English word lecture, so lecture has 5 senses. And the first synset is lecture, public lecture, and talk. We can see these synsets in multiple Indian languages. For example, in Hindi, Vyakhyan, Akhyan, Abhibhashan, lecture. We can see it in, let's say, Marathi, only Vyakhyan. We can see it in Gujarati, and so on. We can see it in multiple Indian languages. So when this happened, we thought, why not we use this resource for multilingual computation? And those were pre-deep learning days. Okay, so we said that we'll go from the word space to word meaning space, which is language independent. So when we did so, we found a way of disambiguating 2 languages simultaneously through a kind of expectation maximization algorithm. So this was the work of Mitesh Khapra, who did his PhD with me. So this example is of disambiguating the word man in Marathi, which has 2 senses, neck and prestige. So we express the probability of senses of man in terms of probabilities of senses of corresponding Hindi translations, Gardan and Gala, and also Adar and Izzat. Okay, and and a coupled equation is also created for Hindi probability probability of sense of Gala in terms of Marathi probabilities. So this is a nice idea where Marathi probability values are expressed in terms of Hindi, and Hindi probability is expressed in terms of Marathi probability. Then you run an expectation maximization algorithm with initialization, and the algorithm converges to give you the sense IDs for both the languages. So when we did this work, we found that the accuracy figure would be about 70% for tourism and health, and that was way above the standard benchmark, which is WordNet first sense. So this was completely unsupervised and in a representation space, which is language independent. So we can call this zero-shot learning, okay, because there is no sense annotated training data. Then we try to see if we can use the same ideas, that means meaning representation, language independent representation for multilingual sentiment analysis. So sentiment analysis is a problem where we are interested in the sentiment value of an entity for a particular feature. The sentiment is held by a opinion holder H at a particular time T. Now, when we applied sentiment analysis algorithms on sense annotated data, then the accuracy improved from 85 to about 86, not much improvement. But cross-lingual experience was much more exciting. When we applied sentiment analysis on Marathi annotated data, we got an accuracy of about 90%. And when we applied zero-shot learning, no training data of Marathi, but Hindi's training data is assumed to be the training data for Marathi, then the accuracy fell to about 85%. But 85% is acceptable in sentiment analysis. Okay, again, completely zero-shot learning, no annotated data of Marathi. And this was made possible because of the WordNet structure. We continue to investigate multilingual computation, one language helping another. in information retrieval scenario. So in information retrieval, a very important parameter, a very important factor is pseudo-relevance feedback, where the query is expanded by keywords taken from the first level of information retrieval. And these keywords are fed back into the query. The search is launched again, and that improves the rank quite dramatically. So what we asked is that if we expand the query with pseudo-relevance feedback, why only from the same language? Why not get this help from other languages also? So when we did so, we found that all the standard parameters of information retrieval, like map value, P at precision at 10, precision at 5, G map, all these values improve by quite a large amount for all these metrics. And qualitatively also, we saw that the information retrieval relevance improves very dramatically. For example, this query, honorary Oscar for Italian filmmakers, had drifted into the direction of Oscar, who was the president of Italy at that time. Okay, but with monolingual pseudo-relevance feedback. So when we translated the query into English, this original query was in French. Then the search engine came back to the proper track with with relevant pages for this query, honorary Oscar for Italian filmmakers. And we saw that not only English, but languages can help each other. Okay, so for this German query, bronchial asthma, when we got the pseudo-relevance feedback from Spanish, then a very important expansion term, which is allergy, and very pertinent to the current problem, came to the expanded query, and that improved the performance of the query. Okay, so in this case, German was held by Spanish. And we studied the influence of different languages on each other. So English was best held by Spanish, German was held by English, Dutch was held by English, and so on. Okay, so this was information retrieval with multilingual pseudo-relevance feedback. Then when we come to machine translation, so in Indian languages, machine translation is always a low resource scenario. We have been working on this since 1996, and we have seen all paradigms of machine translation: knowledge-based, data-driven, under data-driven, analogical, alignment, statistical, and neural. So everywhere there are some critical processes which have to be attended to very meticulously. For example, in rule-based machine translation, analysis plays a very important role. In EBMT, analogy, in statistical machine translation, alignment, and in neural, attention. So we conducted a study on data-driven machine translation for many Indian languages. And as these metrics shows, we had 110 pairs of machine translation systems. And in the Aryan families, of course, had very respectable blue score in the range of 20 to 30. When it came to Dravidian, the blue scores fell very drastically. So if we take the Hindi Tamil system, for example, the blue score was about 12. And for Hindi Punjabi, it was in the range of 60s. Okay, so when we analyzed the results, we saw that in Dravidian machine translation systems, the main problem is with morphological complexity and agglutination. So then we thought that we'll use subword-based machine translation. With morphological analysis, the Hindi to Tamil machine translation system, blue score improved by about 12%. When we applied byte pair encoding, then the improvement was about 21%. Okay, so this showed that for low resource machine translation, subwording is inevitable. But why stop with subwording? Why not take help from another language? So this was cooperative natural language processing or pivot-based machine translation. In pivot-based machine translation, the main idea is triangulation. Suppose we have no evidence of pani translating to jal for Hindi to Bengali machine translation, but we have correspondence from pani to water and water to jal. Now, if we have this kind of small amount of parallel corpus, okay, between pivot and source and pivot and target, again, we can improve the system performance. So this was our first experiment was on Mauritian Creole to English with French as the pivot language. So there, for short sentences, you can see that the blow score improves significantly. We use the same ideas for Indian language machine translation from English to Hindi. And as we brought in other Indian languages as pivot languages, the accuracy improved. Okay. And we, in particular, the Punjabi Urdu combination gave very good blue score for English Hindi machine translation. So this was back in 2014. Now everything is neural now, neural machine translation. And in neural machine translation for multilingual computing, we targeted mainly unsupervised neural machine translation. This is completely zero shot, no parallel corpus. So the first piece of work was done by Sukanta Sen at IIT Patna, guided by me and Asif. And here, the main idea is, of course, denoising and back translation. So as is well known in neural machine translation, syntax is taught by denoising, and back translation facilitates vocabulary learning. So this was the basic framework. And with two languages, denoising and back translation, results were already known. What we did was we introduced multiple languages, and we found that everywhere, for every pair of languages, when we introduce multiple languages, there is a significant increase in the blue score. Qualitatively too, we found that the sentence quality was much more fluent and many times much more adequate. For example, this Spanish to English translation, the reference translation is, students meanwhile say the course is one of the most interesting around. The bilingual baseline system produced, the students by their part say the practice is one of the most intriguing. Multilingual, our system produced, the students by their part say the course is one of the most interesting. So this is very similar to the reference translation. So multilinguality definitely improved the performance. So we moved ahead, and we thought, can we use other ideas too for unsupervised neural machine translation? So we decided to look at the pseudo relevant corpus, okay, the pseudo parallel corpus, which comes from back translation. And we decided to weed out the bad quality sentences. So that we did by making use of blue score. I'm not showing the loss function, how the loss function was changed for this, but results again show that the blue score improves, though slightly. The improvement was, it passed the test of significance. The other idea was that we can use very simple measures like script conversion, some minimal transliteration, unsupervised bilingual embedding, and dictionary word substitution. That actually gave us very remarkable performance for Hindi to Bengali and Bengali to Hindi. You can see that the blue score is about 8 and 12 for Hindi to Bengali and Bengali to Hindi. And Hindi, Gujarati, Gujarati, Hindi, it is in the range of 25 to 33, which is useful even for downstream applications. So a blue score of 25 or so is useful in an actual application too. And this happened because Hindi, Bengali, Gujarati are familiarly close languages. If you remember, the linguistic typology serves as a guiding light in all these discussions. And this theory was correct because we saw that the blue score was pathetically low for Hindi, Malayalam, Malayalam, Hindi, and Hindi, Tamil, Tamil, Hindi, where the languages are from very separate, very different families with hardly any vocabulary overlap. Okay, so the message here was that when we do unsupervised neural machine translation, it will be foolish not to make use of closeness of languages. Okay, so the multilinguality framework here demands looking at the properties of the languages and their vocabulary overlap. So on this multilingual theme, we are continuing our work. The one piece of work which I would like to mention to you is phonemizer-free speech synthesis for phonetic languages. So this is under review. So the idea here is that we normally, when we do text-to-speech system building, there is an intermediate step of phonemizer. Okay, the text is converted to maybe IPS symbols. So from IPS symbols, we do feature extraction like mel frequency values and so on. But we thought that if the language is very phonetic, where grapheme to phoneme entropy is very low, then why have these phonemizer as an intermediate step? Okay, that will save computation and also will not introduce any error because of the grapheme to phoneme conversation. And indeed, we saw that the mean opinion score hardly changes if we remove this phonemizer from the pipeline. Okay, and this work for languages which have almost one-to-one mapping between grapheme and phoneme. We measured the perplexity of grapheme to phoneme conversion for Gujarati, Marathi, Hindi, Konkani, Hindi, Kannada, and English. Okay, Kannada has the lowest entropy when it comes to grapheme to phoneme conversion. So for these languages, we can actually remove the phonemizer and go directly from text to speech. And maybe Professor, I will discuss with Professor Hemamurthy our observations on this. Now, we are also working on multilingual approaches to morphology analysis for Indian languages. So here the goal is to take a word form and obtain the root suffixes and the features, morphological features. So for example, for runs, run is the root word, and the morphological features are present tense, third person, singular number. The affix is S. So we would like to do this for multiple languages together simultaneously by the same neural network. So I show some numbers here. Kannada was studied. So baseline performance for Kannada morphology analysis is about 67. We got some baseline tool for Kannada morphology analysis. So when we introduced data from other languages, that is morphologically processed strings from Hindi, Marathi, and Tamil, the accuracy jumped to 83, okay, which was really remarkable. And the data is SIG-morphon data, which is pretty standard for morphological analysis. We observed the same thing for morphological feature extraction also, and intra-family, inter-family influences were studied quite closely. So one finding from this analysis is that multilinguality definitely helps for morphology analysis. Okay, so even if we have small amount of monolingual data, mixing multilingual data and then doing morphology analysis on neural network, where the representations are learned through the parameters, really helps. And also help from members from another family, from another language within the same family is more apparent than languages from other families. Then we are also working on an interesting problem for positional encoding free Sanskrit processing. We know that in transformers, we have to give the positional encodings. Now, the positional encodings are needed because the case roles, okay, the karak roles are encoded in positions for many languages which are not morphologically rich. Now, Sanskrit allows complete free word ordering because of the strong and regular morphology of the words. So this came from the following insight. If you see the positional encoding in transformers make use of sine and cos. Okay, so why sine and cos? Sine and cos is required because of two foundational observations. So first is that if you have a set of symbols, and if the set of symbols creates a number of patterns, where the number of patterns is more than the number of symbols, the symbols necessarily have to repeat, right? So if you have these 10 digits, 0 to 9, and there are infinite number of integers, surely these digits have to repeat. Okay, so this is first foundational observation. Second foundational observation is that if the patterns form a complete order, okay, so set of integers, real numbers, we can completely order them by less than, greater than, or equal to relation. So if the patterns form a complete order with periodicity, okay, then the symbols also have to repeat with regular periodicity. Okay, this is the foundational observation number 2. So this is verified by binary numbers, for example. So if we take binary numbers, then the least significant digit varies most rapidly. Then the second least significant digit, and then the most significant digit. Okay, so the periodicity is inevitable when we take a set of symbols and create a number system out of it. Now, the positional encoding represents position values, and there is a periodicity, but we cannot use decimal numbers, we cannot use binary numbers because of reasons which I cannot go into right now. So we use sine and cos. Now, this positional encoding we can completely remove and thereby reduce error, reduce computation time for languages which are morphologically very strong. So we are studying this for Sanskrit. So in summary then, multilingual computation is definitely the need of the hour. We described our journey in multilingual computation. In the WordNet-based cross-lingual sentiment analysis, multilingual word sense disambiguation, multilingual pseudo-relevance feedback, and finally, many different techniques of low-resource machine translation which exploit multilinguality and properties of different languages were presented. Future definitely lies in zero-shot, few-shot, and meta-learning involving many languages of the world. And this journey is definitely very exciting. And I must again go back to what I said before. This whole journey began with the training from Professor Sangal, Professor Virit Chaitanya, and so on. Thank you very much.
Can't resist asking a question.
Yes.
The Indo-Aryan and Dravidian, the two contrast that you talked about, how much of this is due to the agglutinated nature and lack of morphological analyzer? Byte pair encoding is not a sufficient technique for handling this. So if you were to put in a morph analyzer in both these and then run the same experiment, my guess is that the difference that you see between Indo-Aryan and Dravidian languages will disappear. One easy way to test the counter experiment is to do a counter experiment with Hindi and Sanskrit. You will find that they are very different. Why? Because you can't handle morphology. You're not handling morphology.
Yeah. So you're saying that if we use byte pair encoding instead of morphology analyzer, or rather morphology analyzer based empty system versus BP based empty system, there will be hardly any difference in case of Hindi and Sanskrit. That's what you're saying. Okay, so the morphology analyzer, okay, first of all, separates the stem from affixes, and the question now becomes how faithfully does byte pair encoding mimic morphology analysis? Maybe that is the question that is coming to. So byte pair encoding is totally dependent on statistical signals. Okay, this is maximum likelihood estimate. And the more the amount of data, better is byte pair encoding's performance. Okay. Morphology analyzer depends on human linguistic competence, understanding of morphological paradigms, creating morphological rules, and so on. So as the data increases, byte pair encoding will mirror human morphological analysis performance. So now, I agree with you that the difference between these two preprocessors for machine translation will be very minimal as the data increases. Okay, so if you're suggesting that don't use byte pair encoding, use morphology analysis, no. Okay, okay. So as the data increases, I think byte pair encoding will become. And Dravidian.
The difference that you see between Indo-Aryan and Dravidian language is purely a matter of, is an artifact of the technique that is available and the amount of data that is available.
Exactly. Agree. Yeah, sure.
Actually, there's something called graphing to TTS, which has been developed a long time ago. And there was something called simple for simple for TTS or whatever. Simple for all.
Okay.
It was developed in the classical techniques itself. And more recently, in the Indian context, we have worked on multi-language character map and things like that. But still, because ultimately in speech synthesis, the consumer is the human.
Yeah.
And we, as humans, when we listen, you want zero errors.
Right.
Okay?
Right.
So, especially because you're listening to the sound, any repetition of the sound, but a schwa not deleted makes a lot of difference. So we have kind of come back to some extent full circle, and we have come with what is called a common label set across all the Indian languages,
right?
Especially in the context of conversation speech. So,
Grapheme to TTS was very popular about 10, 15 years ago. Now it's again coming back. I mean, it's gone now, and
Wow.
then people are going back to this phoneme representations because it doesn't work very well in the context of dialogue. Just a comment.
Yeah.
Another thing is taking on what Sangal said, across Dravidian languages was your blue score when you look at zero shot. Did it work well? You showed the example of Aryan languages, but you've not shown the example of Dravidian languages.
Dravidian to Dravidian?
Dravidian to Dravidian.
Yeah, Dravidian to Dravidian also. Yes.
Okay.
The matrix contained everything. Yeah. So the lower part,
Oh, I see.
this is Telugu, Tamil, and Malayalam, and their values here. So Telugu to Tamil is 12 at that point of time.
Thank you. Actually, I'm tempted to ask
Yeah,
one thing.
sure.
So you touched upon multilinguality, various tasks of NLP and so on. So as you know, Glue benchmark that is kind of set up with a global community.
Right.
I think there is a pressing need now to look at the Indian language setting up something like Glue, and then defining various tasks. And then encouraging people to compete in order to push the benchmark or the state of the art a little bit. So any thoughts on that? Or
Yeah, the evaluation, universal evaluation data, right?
not
For
only that,
multilingual.
defining these problems more clearly,
Right.
and the scope as well as creating the data sets, and then
Yeah. I think the framework is well delineated by Glue. We have to create the data sets and define the metrics properly. Yeah. So maybe this AI for Bharat and all these activities are in that direction. From CFILT also quite a few data sets have been made available. But you're right that you have to take it more seriously.
thank you so much.